Here is a grid with 4 squares shaded in. Shade in one more square to make a shape with a line of symmetry. Remember, a line of symmetry is where you can draw a line down the middle of the shape and have the same reflected on both sides. So we could shade in this square here, because that way we can draw our line of symmetry down the middle, so horizontally, and then we have the same shaded in on both sides. But now we need to shade in a different square to make a shape with a line of symmetry. So we can't shade the same square that we shaded above, we need to shade a different square, which means we need to find a different line of symmetry. Well, if we shade this square here, then we can have our line of symmetry down the middle, because then we have the shape reflected, so the same on both sides. So here we have a vertical line of symmetry. These diagrams show the diagonals of 3 quadrilaterals. So remember, a quadrilateral is a 4-sided shape because quad means 4, and a diagonal is what you get when you join opposite points. So we need to write the names of the quadrilaterals in the boxes. Well, if we join up the points, we can see that here we have a rectangle because our angles are all 90 degrees and we have 2 shorter sides and 2 longer sides opposite each other. Now here, if we join up the points, we have a kite. That's because these 2 lines are the same length, these 2 lines at the top are the same length as well, and opposite angles are the same. So this angle here is the same size as this angle here. Now, it's easy to remember that this shape is a kite because it looks like a kite. But remember, sometimes you might need to turn a shape to see what it is. So here, if we join up the points, again, we have 4 right angles in each corner, or a right angle in each corner, so 4 right angles altogether, and our lines are the same length, so we have a square. Now it might not look like a square at first, but if you tilt your page, you can see that we have a square. The temperature inside an aeroplane is 20 degrees. The temperature outside the aeroplane is minus 30 degrees. What is the difference between these temperatures? So we need to find the difference between minus 30 and 20. So on a number line, we can start at minus 30. And then if we add 30, that will take us to 0. And then to get from 0 to 20, we just need to add 20. So if we need to add 30 and then add 20, that's a difference of 50 altogether because 30 plus 20 is 50. So the difference between these temperatures is 50 degrees. If you're finding a difference and you have a positive number and a negative number, you can ignore the positive and negative signs and just add the numbers to find the difference. 15% of people walk 5 kilometers or less. 40% of the people walk 8 kilometers or more. What percentage of the people walk between 5 kilometers and 8 kilometers? So here we just need to remember that percentages need to add up or total 100%. So we know that 15% is 5 or less and 40% is 8 or more, and that makes 55% altogether. Now because percentages need to total 100%, if we subtract what we have from 100, that gives us 45. So 45% walk between 5 kilometers and 8 kilometers because 15 plus 40 plus 45 is 100 and percentages total 100%. Any number can be written as a product of its prime factors. For example, 20 equals 2 times 2 times 5. So remember, a product is what you get when you multiply, and prime, so a prime number, is a number not in any other times tables, so a number which only has 1 and itself as factors. So you can see what they've done here. They've worked out that 20 is 2 times 10, so they've written 2 and 10. 2 is a prime number, so they don't need to do anything else with the 2, but 10 is a product of 2 and 5. 2 times 5 is 10, so they've written 2 and 5 below 10. And then, to express the number as a product of its prime factors, they've looked at the end of the branches and seen that we have 2, 2 and 5. So as a product of its prime factors, 20 is 2 times 2 times 5. Now we need to write 90 as a product of its prime factors. So, like they did with 20, we can write 90 at the top of our factor tree. 90 is 10 times 9, so we can write 10 and 9 below. But 10 is not a prime number. 10 is 2 times 5, so we can write 2 and 5 below. And because 2 and 5 are both prime numbers, they're not in any other times tables. 2 is only in the 1 and 2 times tables. 5 is only in the 1 and 5 times tables, so we don't need to extend these branches any further. But 9 is in the 3 times table, and 3 times 3 is 9, so we can write 3 and 3 at the end of our branches. So now we have prime numbers at the end. So we have 2 times 3 times 3 times 5. Or we could use a different factor tree. Instead of 10 times 9, we could have 45 times 2. Then 2 is a prime number, so we don't need to do anything else with that. But 45 is 5 times 9, so we can write 5 and 9 below 45. Now 5 is a prime number, so we don't need to do anything else with that, but 9 is 3 times 3. So again, you can see whichever factor pairs you use, we get the same numbers on the end of our factor tree. So that's 5 times 3 times 3 times 2, because if we look at the end of our branches, we have 1 5, 2 3s and a 2. Estimate the size of angle X. Circle the closest estimate. So with angles, there's lots of facts that we need to remember. One is that we need to remember that angles around a point add up to 360. So if we knew what this angle at the top was, we would be able to calculate angle X by subtracting from 360. We also need to know that a right angle, so remember a right angle is like the corner of this screen, angles in a right angle total 90 degrees. But one other fact that we need to know, and that will be most useful for this question, is to remember that angles on a straight line add up to 180 degrees. So if this line here was a straight line, angle X would be 180. But we can see that angle X is just a little bit more than a straight line. It's a reflex angle. So our estimate has to be the number that's a little bit more than 180, because if it was a straight line, that would be 180, but it's a little bit more. So the closest estimate is 190 degrees. Here is a number written in Roman numerals. We have DCCIX. Write the number in figures. So figures just means digits. For Roman numerals, we need to remember that M is 1000, D 500, C 100, L 50, X is 10, V is 5, and I is 1. So if we look at our number, we have D and then 2 C's. So that's 500 and then 2 more hundreds. So that makes 700 altogether. So our hundreds digit is a 7. Then, if we look at the rest of our number, we have ix. So that's 1 before 10, which is 9. But remember, this 7 stands for 700. So we need a 0 as our tens digit before writing the 9. So our number is 709. Programs cost 15 pence each. Selling programs raises £12.30. How many programs are sold? Well, one way to find our answer is to divide £12.30 by 15. But we might not be confident with long division, and the way I prefer is just to count up in steps of 15 pence until we get to £12.30. So we know that one program costs 15 pence. So if we times by 2, we know that 2 programs must cost 30 pence because 15 times 2 is 30. Now, if we times by 10, 20 programs cost £3 because 2 times 10 is 20 and 30 times 10 is 300. And if we have 300 pence, we have £3. Now we need to get to £12.30. And 3 times 4 is 12, so if we multiply by 4, we know that 80 programs must cost £12, because 20 times 4 is 80. So now, because we know that 80 programs cost £12 and 2 programs cost 30 pence, 82 programs must cost £12.30, so our answer is 82. One number is in the wrong place on the sorting diagram. Put a cross on it. So here we have a circle for multiples of 10, so numbers in the 10 times table, numbers that end in a 0. And here we have a circle for numbers greater than 100. So we can see that 105 is in the wrong place, because it's in the circle for multiples of 10, but it's not a multiple of 10 because it doesn't end in a 0. 105 should be written in this section here, because though it's greater than 100, it's not a multiple of 10. Here are 6 triangles. One of them is an equilateral triangle. Put a tick in the equilateral triangle. So remember, equilateral triangles have angles of the same size and sides of the same length. So the equilateral triangle is this one here. All its sides are the same length and all its angles are the same size. So the angles in an equilateral triangle will all be 60 degrees because there are 180 degrees in a triangle altogether. Now lots of these other triangles are isosceles triangles, so they have 2 sides that are the same length and they have 2 angles that are the same, but for equilateral triangles all 3 sides must be the same length and all 3 angles must be the same size.